everyone. I'm Dr. Parker. If we haven't met virtually already on our Zoom call last week, but I just wanted to take you guys into the lab this week so you could kind of get, as close as we can, a feel for the lab environment. So I do have my mask with me, but since I'm the only one in the classroom, I'm not going to use it. But I do want to show you our safety equipment that we're going to use. Obviously, we're going to use our goggles, and you notice that they don't have any holes on the top or the bottom, so they'll seal to your face and make sure you get all kind of good condensation in there. So you want to make sure if you're in the lab, you've got your goggles on. And for those who are coming in class or practice with the glassware, you also do want your mask on. So you want to make sure that that mask fits over your nose and over your mouth, okay? So yes, your whole face is going to be covered, but it's just the nature of the semester. Okay, so first I want to walk you through the lab and show you some of the safety stuff that we have. So let me turn this guy around. So we're going to be in 322 if you're coming into the lab. Notice we come in the door, and if we happen to turn around and look at the door, you say, it says, please do not exit. So we're pretty much going like a one-way stream as you come in the lab, and then we'll have a one-way out of the lab. As you move about the lab, you'll also know that notice that there are arrows that are pointing you in one direction or another, showing you what the flow of traffic should be in the laboratory. And this is just to prevent close contact with other students and making sure that we are orderly when we're walking around the lab. So the first piece of safety equipment that I'll point out is going to be this eye wash station. You see that it just says emergency eye face wash, pull handle to activate unit. So if we do that, you'll see that as we pull this down, that water is coming out. So what you will do is if you've got, if chemicals happen to get into your eyes, which they shouldn't because you should be wearing your safety goggles, but if they do, you'll want to pull that down and put your face into the water and let the water flush out your eyes for, we'll say 30 seconds to a minute, okay? In addition, we also have this safety shower here right on top of it, and there is a very small drain right below it. This unit dumps a ton of water on whoever activates it. So if you happen to spill a large amount of chemical on you that is perhaps corrosive, you would want to use this safety shower, but there should hopefully be no need for that this semester. I've never had to use it, but in the event that you do, it's right by the eye wash, face wash station. As you come in, you see that we've got gloves right here as well. We've got all sizes. If you're allergic to latex, make sure you grab the nitrile gloves, the blue ones, but they're right here at the front for you guys to use. We've got our bench tops here that have their own little gas and vacuum lines. We've got the vent right here that kind of soaks up or pulls any kind of toxic fumes, although we won't really encounter much of that in this first semester. Right behind it, we've got the balance and weigh boats, spatulas, disposable pipettes, that kind of thing. We will go over the balance and how to use this in a minute. So if we move around the room, we see our arrow points this way. Go over here. We'll come across this safety spill kit. Okay, so it's this green and black kit. This kit should be used in the event that you've got a large amount of either acid or base that's spilled that needs to be neutralized, okay? And I'm talking about a large portion, like probably, 100 milliliters or greater. So if you spill an acid on the floor or the bench top, there is a base powder that is used in there to neutralize that acidic solution. Likewise, if there's a base that you spill, there's an acidic powder that's used to neutralize that base, okay? So there's the spill kit. We also have our fire extinguisher here. The acronym that's used to describe how to use this is PASS. It's pull, aim, squeeze, sweep, okay? So that's the acronym used to remember how to use this fire extinguisher. And you can see that we've got a tag here, the white one saying that we are current and that it's been checked, and making sure that it functions properly. Okay, so there's our fire extinguisher. As we keep going, we see we've got these two big fume hoods, and this is where we typically keep common chemicals. So usually the right one, we keep our waste there. We want to make sure our waste isn't seeping out any fumes, so we keep those in the hood and store those in there until it's time for them to be picked up. And then in the left hood, typically we keep our common reagents. So this is where you would go and fill up a small beaker with any sort of reagent that you needed. Keep walking around. We've got our glass disposal box, and here, anytime you break something like a beaker or a Earl flask, you would want to sweep that up using this little dustpan and broom and dispose of it in the glass disposal box. If you did that in the trash can, then we run the risk of our custodial staff who work so hard of getting cut on whatever glassware that you put in there. So we want to make sure that we give them a heads up and say, hey, there's all kind of broken glass in this box, okay? So we designate it that way. Anytime we use pipettes, typically we want to make sure those don't get clogged up, so we just soak them typically for a few minutes. We rinse them off with water afterwards and just return them to our station. Here is our other exit door, okay, or other door that's labeled exit. So when you guys come in the lab, you'll enter through that first door in 322, and you'll exit through this side door, okay? As you guys walk around in lab, you wanna make sure and enter through that first door, come around to the back, and you see that there's arrows that are pointing up. So this is how you'll enter and go to whatever bench top just to sit down if you're just doing some work at the bench top. When you're present in the lab as well, you also want to make sure that you take note of these specific precautions that are described here in the lab. This is posted in the back of the laboratory. Because there are potentially hazardous chemicals present in the lab, you want to make sure that you limit your exposure and your risk. And so to do that, you want to make sure you wear your proper personal protective equipment or your PPE. That includes your safety goggles, making sure you have at least the equivalent of a t-shirt on in terms of the sleeve length. You want to make sure that you have all of your skin exposed from the neck down with the exception of your forearms, that you've got closed-toed shoes on both in the front and that your heels are protected as well, so no slippers. And I think that about covers that. And then we also want to make sure we're not chewing gum, we're not eating or drinking in the lab, and that prevents any kind of internal exposure. I didn't go over the sink areas, but there are paper towels located by every sink. We've also got two different taps. One is just regular water, the other is deionized water. So there's no ions in there. So this is where you can refill your water bottles, which are located at your stations. So every station has a distilled water bottle with the blue top. We also have hand soap for you guys to wash your hands. I'd suggest in the current climate to wash your hands before and after lab. There's also these detergent bottles so you can clean your glassware. There are sponges and brushes for you guys to clean out glassware as well. And we'll just leave that hanging to dry and then put it in a bucket to go through the dishwasher. So I want to show you how to use the balances. So if you go to the balance, it may or may not be on already. But what we can do is just hit the on/off button. And you see that it pops up already. It shows 0.000 grams currently. And so we know that this balance measures out to the thousandths place, okay? And typically when you have a digital readout of a measurement, the error is going to be, or the plus minus will be within that last digit, okay? And if we look on the side here, we see that D equals 1 milligram, okay? So that's that error. So 1 milligram, same thing as 1,000th of a gram, okay? So we see that that plus minus will be plus or minus 0.001 gram, okay? So that means if we weigh something and it weighs 0.554 grams, it could either be between 0.553 and 0.555 grams, okay? But what I do is I just tear it out. It was already set to 0, so I can just put a weigh boat on there, and then I replace this door to make sure there's no draft coming in. So this is that measurement. And if I ever wanted to tear out or zero out this measurement, I would just hit the 0 tear button, and it would make it look like there's nothing on the balance. So then you could go, and if you had to measure out 0.554 grams of something, you could just take your scoopula and weigh that out and just look for that 0.554. The last thing I want to do is give you guys a preview of some of the glassware that you'll be using this semester, and also if you're taking 112 and or 331 or 332, you'll also be taking this information and this knowledge with you to those other courses as well, okay? So the first piece of glassware that I want to introduce is the beaker, and this might be the most familiar piece of glassware to you. It's a very common piece of glassware, but really it's not meant to measure volumes of liquid, even though we see that we could put liquid in here and we see that it holds roughly 50 milliliters. But I will just say that it's typically used to just hold liquids, okay? So we wouldn't use this for a very accurate measurement. Let's say we wanted 10 milliliters of a solution or a solvent. I would not use the beaker to get an accurate measurement, okay? The plus minus on here, it doesn't have that on here. What is the plus minus again? That's the error within whatever device or piece of equipment you're using, okay? So that really says, well, you made this measurement, but it's really plus or minus this, okay? So you can imagine that the smaller the plus minus is, the more accurate or precise the piece of equipment is. This doesn't have it, so the rule that we typically use is we take the smallest graduation that you can visualize with the tick marks, okay? So the tick marks we call graduations. We see there's a tick mark at 10, and the very next one that we have is at 20. So the distance here between the 10 and the 20 is of course 10 milliliters. And then we typically multiply by 10%, okay? So if I took 10 milliliters and multiplied by 0.1, which is our 10%, then I would get 1 milliliter, okay? So it really doesn't seem that bad if I took some liquid, put it at the 10 mark, and made sure that meniscus is right at the top of that line, or that the bottom of the meniscus is sitting right on the top of that line, then it would really be 10 plus or minus 1 milliliter, okay? So the trick to that is if you don't have the plus minus on the piece of equipment, you can make an estimate of the error by taking the smallest graduation, so from 10 to 20, or you could have used 20 to 30, okay? Just the smallest graduation distance, multiplying by 10%, and that gives you a rough estimate of that error. Okay, so beakers, just used to hold liquids, not really measure them accurately. Okay? Maybe I'll use this card, be easier to see. The second piece of equipment I'm going to show you that you will use often is going to be the Erlenmeyer flask. So you see, this is also something that is very common that you might see in movies or whatever if you haven't already taken chemistry before. This is a 125 milliliter Erlenmeyer flask. You see its smallest graduation, and sorry, I'll have to flip this screen around eventually or just show you, but it's 50 to 75. We go from one tick mark to the very next tick mark, and we see we would have 25 milliliters in between there. So again, we don't see any plus minus here. And to be honest, that's most likely because the beakers and Erlenmeyer flasks aren't really used to measure liquids very accurately. So they're going to have a higher degree of error within that piece of equipment. But our smallest graduation is 25 milliliters. If we multiply that by 10%, we would get 2.5 milliliters. So our error within this, let's say you've got a volume of liquid in here that seems to hit at the top of that 75 line, you would say that you've got roughly 75 milliliters plus or minus 2.5 milliliters, okay? So since that error that we can estimate is dependent on that smallest graduation, we cannot say that the error is the same within a 125 milliliter Erlenmeyer flask versus like a 50 milliliter volumetric flask. So it's all dependent on the size of that piece of glassware and how it's made. Okay, what are Erlenmeyer flasks used for? Okay, they're used for mixing. So you notice their unique shape. They've got like a bigger bell bottom and they come up to the top and get smaller, right? So if you look at this, I could hold it easily at the top and I can swirl solutions around, okay? So Erlenmeyer flasks are really used for mixing solutions, dissolving compounds into a solvent, that kind of thing. So they're really used to mix around solutions, okay? You notice if I did that, the liquid would not splash up and fall out like it would in a beaker, right? It's just not as good. That would splash all around, okay? So Erlenmeyer flasks are used for mixing. The next piece of glassware I'll show you, we're gonna get a little more precise with our measurements. If we've got, if we're in need of like 10 milliliters of some kind of solution or 10 milliliters of a solvent, I would probably initially grab a graduated cylinder, okay? So we're getting, this actually is used to measure out volumes of liquids. It's relatively precise. So it's got a tolerance of plus or minus 0.3 milliliters, okay? So that's pretty good versus 1 milliliter or 2.5 milliliters as the error. All right, so this specific graduated cylinder, and they do come in all sizes, is a, let me flip it around, is a 25 milliliter graduated cylinder. You can notice it has a lot more graduation marks, or these tick marks, that are used for measuring volumes wherever that meniscus hits. And you can see if I move this up and down, I can either, I can basically line up the front line and the back line so that they're eclipsing each other. So if I line it up like this, I see a lot less lines. If I flip it around like this, you can see that I'm seeing that back line now. So when you're measuring your volumes, the trick is to look head on so that the front line is eclipsing the back line, making sure you're getting that measurement head on, okay? All right, so there is a tolerance on here, and you see that these measurements, or these tick marks, if you look at, let's say, we'll go between 20 and 25. So if I put this a little bit closer, all right, so between 20 and 25, you guys should be able to tell me that there's 5 milliliters in between this big tick mark and the top tick mark, okay? And that's the bigger line, the bigger graduation, okay? And there are 9 lines in between those 2 big tick marks, okay? So there's 9 lines, so there's 10 spaces, okay? So I can count up to 10. So if I take my 5 milliliters divided by 10, then I will get my 0.5 milliliters, okay? So every tick mark between the 20 and 25 will represent another 0.5 milliliter. So if you count it up, you'll go 20, 20.5, 21. And you'll notice that the 0.5 tick mark is a little bit smaller than the single digit, okay, than the 21, okay? Then you go 21.5 to the smaller tick mark, then 22 to the bigger tick mark. And you keep going up till you hit 25, okay? So that's the trick to figure out real quick. Take your 20 and 25, you know that there's 5 milliliters in between here. There's 9 lines, which means that there's 10 spaces. So you divided the 5 milliliters by the 10, and that gives you how much each little tick mark will go up by. Okay, that's your graduation. All right. So these graduated cylinders are used to measure volumes of liquid. Okay. And the tolerance again is 0.3 milliliters. It says plus or minus 0.3. Okay. So since the tolerance is listed on here, we don't have to make that estimate. Another piece of glassware that we have that is not used to measure volumes of liquid or hold liquids is the Buchner funnel, B-U-C-H-N-E-R. And there's a little umlaut over the U. Okay, you notice that it's a funnel, so we're probably going to be separating something. It's got little holes, and there is a piece of filter paper that will go over these holes to collect any solid. Okay, so the way that this works is that you've got another piece of glassware. It looks exactly like an Erlenmeyer flask, except it's got this little nozzle on the side. Okay, so you've got the filter flask, which is what this is, filter flask. We have a Thomas adapter. So this is just a rubber adapter that will suction the Buchner funnel and the filter flask together. And this goes on top, okay? And this system is going to be hooked up to a vacuum. So you've got a rubber hose here, it goes to a vac line, and it's going to pull air through the system, okay? Remember that Buchner funnel has holes in it, so it's going to suction everything that's on top of it and pull whatever it can down. Typically, it's going to be a liquid that's being separated from a solution. Okay, so Buchner funnel is used to separate solids from liquids within a solution. Must be a heterogeneous solution where you can see those particles, okay? But this is not used to hold or measure volumes of liquids. It's used to separate solids from a solution, okay? In conjunction with the Thomas adapter and the filter flask. All right, 2 more pieces, I believe. If we want to get really precise and really accurate, we would use a volumetric pipette to measure out precise volumes of liquids, okay? And this one in particular, and there are different sizes to these as well, but this particular volumetric pipette is a 10 milliliter, okay, 10 milliliter, and it goes ahead and gives us our tolerance as well, which is plus or minus 0.02 milliliters. So that means if we measure to the only graduation that is on here, so you see we just have that 1 tick mark right on the black, okay, we measure there, put the meniscus right on the line, then we would say that we have measured out 10 plus or minus 0.02 milliliters, okay? So we're getting really close, and we're really minimizing the error within our volume measurement by using this volumetric pipette. There are different sizes as well, and with each different size, you will see a slightly different tolerance or error associated with that glassware. But this one in particular, the 10 milliliters, has a tolerance of 0.02, so plus or minus 0.02 milliliters. Okay. So this is the volumetric pipette. Again, anytime you hear volumetric in front of a name, you can pretty much assure that you're going to have pretty high precision and accuracy with this instrument. Okay. And the last piece of glassware that I want to introduce you to is the burette. Okay. Actually, yeah, I don't see a volumetric glass ground, so we'll just do the burette. This piece of glassware, it's hard to get in the full frame, but it's a 50 milliliter burette, and it's used to dispense liquids accurately. Okay, so you see we have a stopper here, and then I'll bring this up to show you. It's on a little stand. So we've got a stopper here. We can open it to dispense liquids, and then we can securely close it, okay? Depending on how much you've rotated this, you can control the speed of the flow, okay? And it's a little bit different than some other glassware in that you don't go from small to big. You go from, your bigger number is on the bottom here, so your 50 is on the bottom, and the 0 is at the top, okay? Let me see if I can show you. 0 is at the top, okay? So the way that you use this burette is that you figure out how much you've dispensed by taking an initial volume measurement, and then once you dispense your liquid, then you'll take a final volume liquid, so your liquid will be down here somewhere, and then you'll just subtract them to get how many milliliters you have dispensed. Okay, so that's why the reverse is true of this burette, is that the 0 is on top, the 50s towards the bottom, and you do a displacement or a subtraction to get that volume that has been dispensed. Okay, so that's something different about this, but the tolerance on this is not given. So you would do that little trick where you take the smallest graduation available and you multiply by 10% to see what that plus or minus would be. So let me see if I can get a close-up of this so that you can see what that smallest graduation might be. Don't put my hand over the camera, that'd be step 1. Okay, so if we look between 47 and 48, it's kind of hard to see, but you see we've got 9 lines again in between 47 and 48, and so that means there's 10 spaces. So from that knowledge, you should be able to analyze what that plus or minus tolerance or error should be within this burette.